Welcome back. In this teaching video, I'm looking at pure mathematics exam question on recurrence relation, periodic sequence, periodic series. Here is the exam question. A sequence A1, A2, A3 and so on is defined by AN is equal cos squared in bracket n pi over 3. Find the exact values of part A, part 1, A1, part 2, A2, part 3, A3. Please pause the video, attempt part A, part 1, part 2, part 3. Once you've got your complete solution, then play the video. Let's have a look at the solution to part A, part 1. Right, so we want to work out A1. We need to substitute n equal 1 into this formula. Okay, we know that cos squared is the same as writing square bracket to the power 2, cosine inside. So we've got our angle to be 1 pi over 3, which is pi over 3. Okay, we substitute n equal 1. Right, provided that my calculator is on radian mode, if I put this into my calculator, I get a quarter. In the same way, we can actually work out A2 and A3. So part 2, A2 equal square bracket cos 2 pi over 3 to the power 2. This will equal 1 over 4. Part 3, A3 equals square bracket cos 3 pi over 3 to the power 2. If I put this into my calculator, this is equal to 1. This completes part A of the question. Let's move on. Part B, hence, so we have to refer back to our answer in part A. Find the exact value of the sum from n equal 1 to 50 of what we have inside the special brackets. N plus cos squared in bracket n pi over 3. You must make your method clear. Please pause the video, have a go at part B. Once you've got your complete solution, then play the video. Let's have a look at the solution to part B of the exam question. Right, so we've got part B. Now, from part A, we know that A1 is equal to a quarter, A2 is equal to a quarter, A3 is equal to 1. I can continue with this process and work out A4, A5, A6. The reason why I'm going to do this is because that maybe I've got a periodic sequence. I need to check this before I proceed forward with calculating the exact value of this summation. So if I use my calculator, I get A4 is equal to a quarter, A5 is equal to a quarter, and A6 is equal to 1. So precisely we have a periodic sequence. So we have repetitions in cycles of 3. This implies that the order will equal 3 of the periodic sequence. That order 3 is very important in helping us calculate the exact value of the summation. Now let's have a look at that summation. So we've got the sum from n equal 1 to 50. Special bracket n plus cos squared in bracket n pi over 3. Okay, we can open the sum into two parts. So we've got the sum from n equal 1 to 50 of n plus the sum from n equal 1 to 50 of cos squared n pi over 3 in brackets. Let's start off by evaluating this sum over here. So the sum from n equal 1 to 50 of n. If I substitute n equal 1, I get 1. So the first term of the series is 1. Plus, if I substitute n equal 2, I get 2. Second term of the series is 2. So we've got 1 plus 2 plus 3 plus ... plus the final term. If I substitute n equal 50, I get 50. Right, so this over here is the sum of the first 50 terms of the series. Over here, we notice that we have a common difference. Each time we're adding 1. So it is an arithmetic series. We're going to calculate S50 using the formula Sn equal a half n in bracket a plus l. We can use this formula because we know the last term of the series. So the S50 is equal to 1 over 2 multiplied by n, which is the number of terms. We're looking at 50 terms, multiplied by, in bracket, a, the first term of the arithmetic series is 1, plus l, the last term of the arithmetic series is 50. Okay, so I can put this into my calculator and this gives me 1,275. Okay, so I've got 1,275 plus this particular summation. Right, let's have a look at evaluating this sum now. So we've got the sum from n equal 1 to 50 of cos squared in bracket n pi over 3. Now we know that this over here, ladies and gents, is technically an. So I'm going to replace this with an. So I've got the sum from n equal 1 to 50 of an. I'm going to open up the summation. Okay, so if I open up the summation, this is equivalent to a1 plus a2 plus a3 plus a4 plus a5 plus a6 plus dot 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 plus a49 plus the last term, which is a50. Okay, so this is equal to, I can replace these terms with the numerical values, a quarter plus a quarter plus 1, a quarter plus a quarter plus 1, plus dot 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 plus a49 plus a50. So I can put a bracket around the sum of these three terms, put a bracket around the sum of these three terms. Now I need to determine how many repetitions are there of these brackets over here. To do this, I take the number of terms, which is 50, and I divide by the order of the periodic series. So the order is 3. So 50 divided by 3. This gives me 16.66 dot dot dot. I'm going to round down. So if I round down, I'm looking at 16. So 16 repetitions, so 16 lots of a quarter plus 1. How many terms will this cover? So it will be 16 times 3, 48 terms covered. So if 48 terms are covered, this implies that the repetition would start again at A49. So A49 must equal a quarter. And so A50 is also equal a quarter. Right, so I can simplify this particular summation. So this will equal 16 lots of a quarter plus 1 plus the A49. So the A49 is a quarter, as explained, plus the A50, which is also a quarter, as explained. Right, so now I can put this into my calculator, and if I do this, I get 49 over 2. Right, so I can go back over here. I've got 1,275 plus the value of this summation here. The value of this summation is 49 over 2. And ladies and gents, I am getting closer to my final answer. So my final answer will be 2,599 over 2. That is the exact value of this beautiful summation. How beautiful is that? Amazing. Okay, so that completes part B of the exam question and this teaching video, pure mathematics exam question on recurrence relation, periodic sequence, periodic series. If you found this teaching video useful, please don't forget to subscribe, leave a like, leave a comment, turn on your notification bell so that you receive notifications every time I post a new teaching video.